In continuation with the P block elements, we are continuing with nitrogen family. Few more important questions of nitrogen family. Question number 1. What happens when ammonia is added to copper sulfate? Copper ions, you can say. Answer: ammonia forms tetraamine copper 2 sulfate complex, giving blue color to the solution. So reaction will be copper 2 positive ion in aqueous state combined with 4 ammonia molecules, giving you tetraamine copper 2 sulfate. This has deep blue color. Then we have question number 2. Give laboratory preparation of N2 gas. So N2 can be prepared by adding sodium nitrite ammonium chloride treated with sodium nitrate, you will get NaCl plus N2 plus 2 water. So this is lab preparation of N. Question number 3 is why N2 is chemically inert but P4 is reactive. As we know, N2 has high bond energy, that is 941.5 kilojoules per mole. That's why it does not react easily. As compared to phosphorus, which has very less bond. इसकी बॉन्ड एनर्जी बहुत कम होती है. Discuss disproportionation of phosphorus acid. This is also an important question. When phosphorus acid disproportionates, it will produce phosphoric acid. Along with that, it also produces phosphine, which is also an inflammable gas and is also used as a fuel in rockets. So we have next question. Discuss disproportionation of phosphorus acid. Disproportionation means the same element on decomposition of a compound changes its oxidation state. In one of the compound it has higher oxidation state than the starting compound, and in another compound it will be having lower oxidation state. For example, when we heat 4H3PO3, it will give you 3H3PO4 plus PH3, phosphine gas. Here phosphorus is present in plus 5 state Here it is in +7 state. In this case it is in +3 state. So for +5 state of phosphorus has now changed into 2 oxidation state. In one of the compound it is in the lower oxidation state, while in other compound it is present in the higher oxidation state. Then we have, what do you know about boiling point of hydrides of nitrogen family? So comparing their boiling point, NH3 has maximum boiling point as well as melting point. क्यों ज़्यादा है? Because due to hydrogen bonding in it. Second point is phosphine has least boiling point and melting point due to very weak van der Waals forces. But other members have order. Bi3 has maximum than stilbene and it has more than ASH3 arsine. Because magnitude of van der Waals forces increases when we move from arsine to bismuthine, which increases the boiling point in the lower member. If we plot a graph between boiling point, it will be like this. Here you will be having ammonia both in case of melting as well as in boiling. Then you have phosphine least, then we have arsine, then we have antimethane, and in the last we have bismuthine. This will be the graph for boiling point of the hydrides of nitrogen family. Why Ncl3? Next question is, why Ncl3 get hydrolyzed? It get hydrolyzed easily while NF3 is not. The reason for this is, in Ncl3 chlorine has vacant d orbitals to accept electrons from water molecules, while in NF3 fluorine does not have any vacant d orbital to accept electrons from the water. Therefore Ncl3 gets hydrolyzed by water, but NF3 is not hydrolyzed by water. Then we have the question, what is the action of heat on nitric acid? As we know, nitric acid on heating decomposes to give you 2 water molecules, 4NO2 and oxygen gas. So nitric acid on heating get decomposed to produce water, NO2 gas and O2 gases. Then we have what happens when ammonium dichromate and sodium azide, they are heated. Both of these compound on heating, they will liberate nitrogen gas. That's why this method is also used for the preparation of nitrogen gas in the laboratory. लैब के अंदर नाइट्रोजन गैस बनाने के लिए we use these 2 compounds. What happens when NH4 twice Cr2O7 and sodium azide are heated? Answer is both liberate nitrogen on heating. So first of all, we take ammonium dichromate, heat it, you get N2 plus you get 4H2O plus Cr2O3. Similarly, when we heat sodium azide, then we get 2Na plus 3N2 gas. So in both cases, nitrogen is produced. So this method is also used as a test, as a laboratory method to prepare nitrogen gas. Now give the preparations of oxides of nitrogen. Different oxides of nitrogen preparation as well as structure also. So give the preparation as well as structure of different oxides of nitrogen. Number one is laughing gas. Laughing gas name is given to it because whenever it is smelled in excess, it produces laughing. So it can be obtained by heating ammonium nitrate. You will get N2O plus 2 water is obtained. This is laughing gas, structure of laughing gas. This is the structure of laughing gas. Then we have second oxide, that is NO, nitric oxide. It is prepared by heating parasulfate with sulfuric acid and dilute HNO3. So you get Fe2SO4 thrice plus H2O plus NO. This is nitric oxide. Structure of nitric oxide is like this. It can also be obtained by heating ammonia 4NH3 plus 5O2 in the presence of catalyst iron molybdenum 773 Kelvin. You get 4NO plus 6H2O. So this is second oxide, that is nitric oxide. Then we have N2O3, dinitrogen trioxide. It can be obtained by heating NO with NO2. You will get N2O3. Structure of this oxide is this is single bond. This is N2O3. Then we have fourth N2O4. 2NO2 on heating can give you N2O4. This is dinitrogen tetraoxide. Then we have NO2. Its structure is similar to N2O3. Both sides of nitrogen will have 2 oxygen each. Then NO2. How to get NO2? By heating lead nitrate. You get 2 PbO plus 4 NO2 plus O2. Structure of NO2 is like this. This is NO2. Then we have N2O5. It can be obtained by treating HPO3. HPO3, 4 molecules of HPO3, they are heated with HNO3. H4 molecules of this, they are heated with P4O10. You will get P2O5. We want to prepare N2O5. It will be prepared from 2HNO3. N2O5 plus 2HPO3. This is N2O5, structure is like this. This is N2O5. Then we have a very important question which is often asked in the examination. That question is, what is ring test for nitrate ion? Discuss chemistry of ring test or nitrate ion. The salts containing nitrate ions, when they are treated with freshly prepared ferrous sulfate solution followed by mixing with H2SO4, which is added across the walls of the test tube to avoid the explosion, to avoid the bumping of the solution out of test tube. And this solution in the test tube is allowed to stand for some time. After some time you will see two junction of the liquids, and at the junction of these two liquids you will find a brown colored ring. That ring is due to formation of pentahydrate ferric nitroso ion. तो ये आयन बनता है, रिएक्शन कैसे होती है? Let us see. NO3 negative ion combined with 3Fe2 positive ion जो कि ferrous sulfate ने सप्लाई किए, और sulfuric acid will supply H positive ion. They will change into NO plus 2H2O plus 3Fe3 positive ion. ये जो ferric ions बन गए, they will now accept 5 water along with nitric oxide. They will form FeH2O5NO, and this is 3 positive. You will get dark brown ring. So due to formation of brown ring at the junction of two layers, this test is also called as ring test for nitrate ion, because we are getting a ring here. So this is a very important question, ring test of nitrate ion. Now what is Haber's process? It is a industrial process which is used in the preparation of ammonia. What is done in this case? The mixture of nitrogen and hydrogen in the ratio of 1:3, they are passed over catalyst iron and molybdenum at 773 Kelvin and 200 atmosphere to get ammonia. The mixture of N to N hydrogen in the ratio of 1:3 is passed over iron and molybdenum at 773 Kelvin and 200 atmosphere to get ammonia. So we get N2 plus 3H2, iron, molybdenum, 773 Kelvin, you get 2NH3 and 200 atmosphere. Now this reaction is actually a reversible reaction. To get more ammonia, temperature should be low. Second is pressure should be high because number of moles of product are less. Gas is pure. Catalyst pure. Impure होंगे, they will spoil the reaction. They will not give good quantity of ammonia by this method. So this is Haber's process, and Haber's plant consists of, initially we will be taking two tubes. From one tube we will be supplying nitrogen gas, which is obtained by liquefaction of air. Another tube is by hydrogen. Before going to the chamber, they are compressed. This is compressor where gases are compressed to a pressure of 200 to 900 atmosphere. Then these compressed gases, they are passed through another chamber which is packed with iron and molybdenum. This is Fe molybdenum chamber. Here the gases combine and produce ammonia gas. And this ammonia gas, it is then passed through cooler coils and then they get collected in another chamber. This is called as absorber. So liquid ammonia is collected at the bottom. From here it is withdrawn. This is liquid ammonia. So first part is preparation of gases, then we have compressor, then we have combination of nitrogen and hydrogen to give ammonia, reaction chamber, or we can call it as a converter. Then we have liquefaction. Here, if some of the nitrogen and hydrogen they have not reacted, they are passed back to this chamber. So this is the Haber's process for preparation of ammonia, ammonia gas. Then give uses of ammonia. कुछ uses हमें ammonia के बताने होंगे. First use है, it is used in the preparation of smelling salt. Cold के दौरान we get number of such inhalers which reduce the intensity of the cold. These salts they contain mixture of ammonium carbonate and ammonium bicarbonate. उनमें अमोनियम कार्बोनेट और अमोनियम बाइकार्बोनेट का मिक्सचर होता है और वो जो है कोल्ड की फ्रीक्वेंसी को कम कर देता है. So it is used in the preparation of inhalers to reduce the cold. In the preparation of fertilizer like calcium ammonium nitrate, ammonium phosphate, etc. Liquid ammonia is also used as refrigerant, and it is used in ice factories and cold storage. It is also used as a laboratory reagent and cleansing agent. Then we have give reactions of dilute HNO3 with H2S and acidified ferrous sulfate. So first of all, we will take the main reaction of dilute HNO3. It will decompose to give you 2H2O plus 2NO plus nascent oxygen. 3 nascent oxygens are produced. So dilute HNO3 is a strong oxidizing agent as compared to concentrated nitric acid, which on decomposition produces only 1 nascent oxygen. this nascent oxygen will now attack H2S. You will get 3 water plus 3 sulfur. When you add this equation, oxygen will be reduced. 3H2S plus 2HNO3 dilute. You will get H2O 4 molecules plus 3 sulfur plus 2 NO. Then we have second reaction, action on ferrous sulfate. Take the first reaction as such. You will get H2O plus 2 NO plus 3 nascent oxygen. This will combine with ferrous sulfate in the presence of sulfuric acid and nascent oxygen is consumed here 3. You will get Fe2SO4 plus H2O. If you take one oxygen here, multiply it by 3, you cancel these oxygens, you will now have 6 FeSO4 plus 2HNO3 plus 3H2SO4. Product will be H2O4 H2O plus 2NO plus 3Fe2SO4. This is called as ferric sulfate. Then we have third reaction, action on H2S. First of all, same reaction is written. 2HNO3 dilute breaks out to give you H2O plus 2NO plus 3 nascent oxygen. This nascent oxygen will now attack on SO2. So SO2 combines with water and one nascent oxygen to give you H2SO4. You add this equation and multiply oxygen with 3, you will cancel it. SO2 will remain here, SO2 plus 2HNO3. Here you have 1 water, 2 water, 1 water, they are being cancelled here, 2NO plus H2SO4, 3H2SO4 will be there. So these are the reactions of your dilute HNO3 on different compound. Now what are the uses of HNO3 concentrated? It is used as laboratory reagent in the preparation of fertilizers, in the preparation of dyes, in the preparation of explosives, in the preparation of rocket fuel. It is used as a oxidizer, and in the preparation of large number of aromatic nitro compounds which are used as a fuels, or sometimes they are used as explosives. Then do you know the method of preparation of PCl5? Give two methods to prepare PCl5. PCl5 can be prepared either by treating a phosphorus directly with chlorine or treating PCl3 with Cl2. So we can get PCl5 by both methods. P4 can combine with 5Cl2 to give you 4PCl5. PCl3 when combines with Cl2 it will also give you PCl5. Structure of PCl5 is trigonal bipyramid. Since it is the repulsive interaction between these axial chlorine bond pairs and equatorial bond pair that is more, therefore this molecule is unstable and easily breaks up to give you PCl3 plus Cl2. So these are the preparation of PCl5. They are done by two methods. Why NO becomes brown on exposure to air? Why NO becomes brown on exposure to air? It is due to oxidation of NO. It combines with the aerial oxygen to give you 2NO2, which is brown colored. So NO becomes brown on exposure to air. Why PCl5 fumes in air? PCl5 fumes in air. इसका मतलब यही है कि PCl5 को अगर हवा में रखा जाए जिसमें मॉइस्चर हो तो वहाँ पे ये भाप सी पैदा करता है. It produces just like steam as in winter season. What we see, the vapors coming out of our mouth, they get freezed and a type of smoke appears coming out of the mouth. So we are doing the same. Why PCl5 fumes in air? It is due to hydrolysis with PCl5 or PCl3. It is due to hydrolysis with the moisture of the air. PCl5 first of all breaks to give you PCl3 plus Cl2, and this compound PCl3 can react with H2O to give you 2PH3 plus HCl. HCl के जो हैं fumes आपको मिल सकते हैं. PCl3 reacts with 3 water and will give you H3PO3, not phosphine. It will give you H3PO3. Along with that, it will produce HCl. तो HCl के आपको fume मिलेंगे. Cl2 also reacts with moisture. It can produce HCl fume plus nascent oxygen, which combines with other oxygen to give you O2 gas. Now, bond angle PCl5, एक question और है, why PCl5 exists in the nature, Ncl5 does not. We have done answer to this question. Phosphorus has vacant d orbital, that's why it can extend its coordination beyond 3 and form PCl5, but nitrogen has no vacant d orbital, therefore it can not form the pentahalides. Then why BiS3 is the strongest reducing agent? The reason for this is Bi has weak bond with hydrogen, so on heating it can release hydrogen and can serve as a good reducing agent. Then R3PO exists. Question is why R3PO exists. ये पाया जाता है, but R3NO does not. रीजन इसका वही है कि फास्फोरस में vacant d orbital हैं. That's why it can extend its coordination number, but nitrogen has no vacant d orbital. That's why R3NO is not possible. Then we have the question, what is Ostwald process? Ostwald process, जैसा कि अभी हमने देखा, Haber's process, which is used to prepare ammonia in the lab industry. Similarly, we have Ostwald process, which is used to prepare nitric acid in the industry. Question is, discuss manufacturing principle of Ostwald process. Ostwald process principle क्या है? In this method, mixture of ammonia and oxygen in the ratio of 1:10 is passed over heated platinum rhodium gauge to get NO, which is oxidized to NO2, and when dissolved in water, जब इसको पानी में घोला जाता है, and oxygen, it gives nitric acid. So what are manufacturing principal reactions? 4NH3 combines with 5O2 at 1073 Kelvin. Catalyst is platinum rhodium gauge. You will get 4NO plus 6H2O. This NO combines with oxygen in the oxidation chamber. This is called as oxidation reaction. It will give you 2NO2, and NO2 when dissolved in water in the presence of oxygen, this reaction happens in absorber. This reaction happens in oxidation chamber. This reaction happens in converter. It will produce 4HNO3. So this is post-Wald process of preparing nitric acid. Now arrange the different oxides in order of increasing, or different oxides of nitrogen in order of increasing their acidic strength. As a arrange different oxide nitrogen in order of increasing acidic strength. तो इसमें आपको जिसका ऑक्सीडेशन नंबर ज़्यादा है, यहाँ नाइट्रोजन +5 स्टेट में इट इज़ मोस्ट एसिडिक, देन वी हैव N2O4, इट इज़ देन सेकंड मोस्ट एसिडिक, देन वी हैव N2O3 वेयर नाइट्रोजन इन +3 स्टेट, देन वी हैव NO2, इसके बीच में NO2 आ जाएगा वेयर नाइट्रोजन इज इन +4 स्टेट, यहाँ +3 स्टेट में ये दोनों बराबर एसिडिक गुण रखते हैं NO2 और N2O4, देन वी हैव NO where nitrogen is in +2 state, then we have N2O where nitrogen is in +1 state. So the acidic strength of oxides of nitrogen that depends upon the, you can say, the oxidation state of nitrogen. Then we have give one preparation of phosphine, calcium phosphide. We have question number 7, give one preparation of phosphine. फॉस्फेन को बनाने के लिए कैल्शियम फॉस्फाइड heated with water, you get 2pH3 plus calcium hydroxide. So calcium phosphide when hydrolyzed with water will take 6 water molecules there. You will get 2pH3 plus you get calcium hydroxide. So this is the hydrolysis reaction, Ca3P2, you will get 3CaOH twice here. How is black phosphorus prepared? This is also a very important question of nitrogen family. Black phosphorus is prepared by heating white phosphorus at 470 Kelvin under high pressure of 4000 to 12000 atmosphere. तो अगर white phosphorus को आप हीट करें 470 केल्विन पे अंडर 4000 to 8000 atmospheric pressure पे, it will give you black phosphorus. It has multi-layered structure. These are having P4 units only. Now give two important uses of phosphine. Number 1, it is used to prepare smoke screens in the warfare and in the home signal. Home signal जो लैब आपकी जो माइंस हैं वहाँ पे टू नो द पोजीशन ऑफ रॉक्स वी यूज दिस गैस इन द होम सिग्नल which is the most abundant element in the earth crust after oxygen, nitrogen. Oxygen is the most abundant element in the earth crust. Then write some molecules which have the crown-like structure. So these molecules are basically the molecules of oxygen family, S8, Se8, Te8. Then what is inert as sphere effect? We have already defined this effect. Inert as sphere effect, it is the tendency on the part of S electrons not to participate in the chemical reaction. S electrons के part पे ये tendency रहती है that they do not participate in the chemical reactions due to poor shielding effect of the D and F electrons. These electrons, they do not readily participate in the reaction, or if they participate in the reaction, they will immediately tend to revert back to their original position. वो अपनी original position में आने की दोबारा कोशिश करेंगे. So these are the few questions. Then this is all about our nitrogen family. And nitrogen family में आपके पास nitric acid है, which is a very important component of aqua regia. Aqua regia is a mixture of HNO3 and HCl in the ratio of 1:3. which can dissolve all the noble metals. Noble metals, they do not dissolve in pure acids, but when aqua regia is prepared, they easily dissolve. For example, we have HNO3 one part, 3 part HCl. They are mixed together, you will get 2H2O plus NOCl and chlorine. ये जो chlorine है, it can dissolve noble metals to give you PtCl4. It can combine with gold 3Cl, you will get AuCl3. It can combine with copper to give CuCl2. So you can be asked, what is aqua regia? How it dissolves noble metal. Noble metals को ये कैसे dissolve करता है? We have seen these are noble metals which do not react under general conditions, but under the aqua regia they react. So this is all about our nitrogen family. Tomorrow we'll take with the other family, that is oxygen.